So now we're going to talk about some of the hardware. So as you can see, this is a large variety of hardware, so we're going to talk about each one individually. So to start with, you have your basic screw. Okay? So this screw is an 832. 8 is the size of the screw diameter-wise, so that way. It's 8 that way, and 32 is the number of threads per inch. So that's written down as, bear with me, that's written down as 8-32. So if you're interested in what that is, it's an 832 motor screw, or just regular screw. And as you can see, we have all different sizes. So there's a 1/4 inch, there's a 3/8, there's a 1/2 inch, a 3/4, etc., etc. And you can tell what that is if you take a ruler, you look at the ruler, and you put it up on the ruler, you can see it is 1/4 inches from the bottom of the head to the end of the thread. It's 1/4 inch. And then this one is 3/8, etc., etc. And then the reason we have different sizes is because you may need to do different things with them for different distances. If you only need to join two pieces of metal together, this standard 1/4 inch is going to be perfect. But if you need to go through a bearing block, for instance, which we'll talk about in a second, you may need to use a 1/2 inch or a 3/4. So there's the 832 screws, and there's all different sizes. So, and then to control an 832, to drive it, you need to use a 3/32 Allen wrench, which this is the standard Vex Allen wrench. As you can see, it's a T handle, which means it's shaped like a T. And at the top there, you can see it says 3/32. 3/32. And then that has a hex end on it. And this one is kind of rounded over, and that's kind of bad. But what you want to do is, you can see at the top of the head, it's also hex shaped. Maybe hard to see, but you can see on yours fairly easily. So to drive it, you don't use a standard Phillips head. You use this little T wrench, and so it's an Allen wrench. It's a hex wrench. And then that's what drives it. So you can spin that, and then that will screw it in. And that gives us more surface area, so it's less likely to strip out. But sadly, this is fairly poor steel, and then the Allen wrenches are made of fairly poor steel as well. So if you look there, you can see how it's kind of silver on the end, and it's kind of rounded over. That's because when you put this in here, and people try to tighten them really, really hard, and it pops out, then you end up taking some of the material off of the wrench, as well as inside the screw. And you can see, if you look at some of the screws, the new screws are very defined. They have very nice straight edges of the hex. And some of the older screws, like this one, it's very scratched up. And then the edges are not nearly as defined. And some of them are so bad that they're actually completely round, and you can no longer drive them. So whenever you build, you always want to make sure you use good screws, because if your screws are stripped, it'll be a nightmare to take them off. As a 4-year veteran, I can testify that the most annoying thing with Vex is when you can't get that screw off and it's stripped, and you're sitting there, and the screw is sitting there, and you're spinning the Allen wrench, and it's not coming out. So be careful with your screws. These are the old screws. They're Vex, or they're black. They're black screws. The newer screws are more of a stainless steel, and they're silver. Those are preferred because they don't strip out as much, but we don't have nearly as many of them. So when you use these, just be very careful to make sure you get screws that are not stripped. If you find any that are just extremely stripped and they're just no good anymore, throw them away. Okay? We don't want someone accidentally picking them up in the rush of building their robot and then having a strip screw and just a bad time. So the 832 Allen screws, and the Allen wrench. So we have 30 different kinds of Allen wrenches. We have this kind of T wrench, which is really nice, so you can get a good bit of torque on it. You want to be careful about putting too much torque on your screws. And then you can also spin them like that. So if you need to do a lot of screwing, you can take it like that and roll it in between your fingers, and now spin it, and you can get a screw in pretty fast by doing that. So I like those. And then we also have this kind of Allen wrench. As you can see on the end here, it has a ball on the end of it. And that ball should be hex shaped to an extent. So what this will allow you to do is allow you to put your screw in here, and instead of being limited to going straight on like this, you can angle your wrench like this and then still drive it. So if your wrench is like hidden beneath the overhang like that, and you can't get your wrench in there, because if you try to get your wrench in there, it doesn't really fit because that thing's in your way. This will allow you to get it in there and then still drive it. So in a tight place, these are awesome. These little ball head Allen wrenches. And you can tell at the top there, at the top it says 3/32 on the top of the Allen wrench. So those two. And then if you've worked with Allen wrench before, you know the classic L-style Allen wrench. It's just like that. And then the entire thing is a hexagon. So you can put your screw on this end, or you can put your screw on this end, which is great. So you can, I don't have any with me, but you can put the screw on this end, and then you have a whole bunch of leverage to tying it in, tying it down and everything. And it's really nice for really nice tight spaces where neither of these really fit very well. So those Allen wrenches, those screws, and just be careful over tying your screws. That's the biggest hint. Don't over tying your screws. So there's 832, and those are used with like Kep's nuts. There's a Kep's nut, and as you can see, it's a standard nut. It's threaded. It's threaded on the inside, and then it has this little free spinning washer kind of doodaddy on the end here. And what that's designed to do is designed to lock onto the metal. So when you put two pieces of metal together, you'll take a screw, you'll put this in here just like this. Make sure that this part of the nut, this little spinny part of the nut, is in between, is on the facing your metal like this. And then you'll just take your wrench and you'll tighten it down until it stops. And what that spinning part will do is it'll compress and it'll prevent the nut from coming loose prematurely. And these are really nice because there's no tension when you're trying to put it on. And these are the most common nuts that we have and probably most preferred. But these do come loose from time to time. So if you need something like extra secure, you can use a nylon nut, which I don't have with me. A nylon nut doesn't have this little thingy on it. Instead it's thicker. It's physically thicker this way, and it has actual nylon in it. So it has a piece of like fabric material glue kind of thing. So what it does is it provides extra tension on the threads, on the actual threads of the screw, to prevent the screw from coming out. So that's great when you want to make sure that nut stays on there, does not come off, and needs to be tight all the time. And you don't want it coming loose, because if that screw comes loose, then the entire robot comes apart and fails. But most of the time, these Kep's nuts will work perfectly for you. And then the downside about the nylon nuts is if you need to put a nylon nut from all the way from the end of the screw all the way down to here. First off, you don't want to use a long screw if you don't have to. You want the shortest screw possible. But because there's friction inside the nut, it's difficult to bring the nut all the way down to the end here, because you're constantly trying to put a lot of force on it just to get it in there. Imagine if someone was holding the screw really tightly and you're trying to screw it into their fingers. It's really hard because there's always pressure on it. Alright, so there's a Kep's nut. And to hold a Kep's nut in place, so you can hold the screw via one of the screwdrivers, like so. But then, this guy, if he's just sitting there, he's not going to go in like that. So what you'll need sometimes is you can use your finger to start it like that until it gets to the end. But to tighten it down, you use one of these wrenches. There's two different size wrenches on it. There's a big side and a low side. We're going to use the big side for these. So that, as you can see, it fits on there just like so. And then that will allow you to hold that with a lot of leverage and then screw your screw in, just like so. And that'll go all the way down until it stops, and you can tighten it down. You can give it a nice final twist to tighten it down really, really securely. So there's your nuts and your screws. They're the most commonly used to join your metal together. But you may also be using a standoff. So what a standoff is if you need to put two pieces of metal together, but you don't want to smash up against each other. You want like a small gap in between them. So what you'll use is one of these standoffs. And there are different sizes. The most common ones we have is we have a ½ inch, a full inch, 2 inch, and 3 inch. Those are the most common sizes we have. But what you'll do is you'll take one of your A32 screws, your standard size screw, and you'll take it and you'll put it on the end here, just like so. And then you'll tighten that down. And then you'll put a piece of metal right here. So then you've then secured that to your piece of metal. Then you have this little end on here. So then you take another one of your screws, you put a piece of metal on it, and you tighten that down. So then you can tighten that down and put it in there, and then you have a piece of metal on this side, a piece of metal on that side, and then this standoff will prevent that metal from getting too close. It'll keep it apart. Exactly 1 inch apart. You can use ½ inch, 1 inch, 2 inch, 3 inch, whatever you need. We have different sizes, and the Vex has different sizes, so we need to get those as well. So those are standoffs. These are standard 832 screws. And then, but what if you don't want to use a standoff? Well, we also have spacers. I know it's a really long video. I'm trying to get through everything, but you can come back and speed through and find what you need. We also have spacers. So the oldest kind, the original kind, were these kind of spacers. They were these black, tiny, diameter-wise, they were tiny, these little black spacers. They came in two sizes. They came in this small size, and they came in this big size. So if you need a small spacing, you could use that. If you need a big spacing, you can use that. But now they've released these, I believe they're neoprene plastic white style spacers. And then they also have different sizes. They have more sizes than what I have here. And you can get all kinds of different sizes. They have smaller than this size, they have that size and that size. So you can do a larger combination. So if you need something that long, it's really easy to get something that long, where before it would take a whole bunch of these to make something that big of a spacing. And these are great for when you have an axle. I didn't talk about an axle yet either, but an axle is a square shaft. If you look at it from the end, it's square. Okay? And this axle is what everything pivots on. So this fits inside of your motor. If you look inside your motor also has a square end on it. So this goes in there, and then that's what drives that's what provides the motion for all of your robot. So that's how it connects to your motor. And then, for example, you want to put a wheel on it. The wheel also has a square point in the center. So then this slides on there, and then when the axle spins, the wheel spins. So then you'll put the motor on the end of it, like so, and then when the motor spins, the wheel spins. So then that's how you would control your drive. We'll get into that more later. But let's say you wanted to make sure that the wheel doesn't get too close to the motor. You don't want it to slide up and get in the way of the motor. You can take some of your spacers here, put your spacers on, and you put whatever combination of spacers you need. Preferably you want to use larger spacers and then smaller spacers until you get to the right distance. And then that way, when you put it on, you can bump it up tight, and now keep your wheel away from your motor or whatever moving part you need. So then we'll get into that more later, but that's what the main purpose of the spacer is. And as you can see, they'll spin freely. Alright, so that's the axle. And then we also have these bearing blocks. So these bearing blocks are really helpful because in a piece of metal the metal has square holes. Yeah. And if you have a square axle and a square hole, what will happen is that it'll rotate in there and it'll start wearing away at the metal, which we've had this really, really bad, and it'll actually make a large, ginormous hole in here, and it'll destroy the metal, it'll destroy the axle, and it won't run properly. So what these bearing blocks do is, I'll have a whole video about these bearing blocks, because they're very helpful, and most people don't know how to use them. These bearing blocks fit onto the metal just like that. And what that does, it provides a nice circular piece, a nice circular pivot for the axle to roll in. And it's very, very, very smooth. It reduces friction in your system, and it will prevent your robot from being destroyed, and your metal from being destroyed, and running properly, and very, very precise. So we'll get into bearing blocks in a little bit as well. And the other thing you'll have for an axle is you'll have a collar. So a collar is just a round piece like this, and it has a tiny little set screw. So if you look at the set screw will come out just like that. But we don't want to lose these. They're really, 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 really tiny, okay? So don't lose these whenever you can. Try to make sure they're always in the inside the collar. Now, as you see on the end, they have a tiny, tiny little hex. And sometimes, these are what gets strips are almost the worst, is that since it's so tiny, you can easily strip these out. And what these do is that when you put the set screw and you turn the set screw in, you can look inside that hole, and then you'll see the screw going inside of the collar. And what the collar does is it goes onto your axle, just like so, and you can see it'll spin. That's because it's round. What the collar is designed to do is to stay in place on the axle. So as you can see, it can slide side to side. But let's say you wanted to keep something right there. So what you'll do is you'll put the collar on there, line this screw up, the plane of this screw with the plane of one of these sides of the axle, line it up, and then screw that down and give it just a tiny bit of a turn, a little tiny bit of tension, not very much. And then sometimes it'll get stuck. Just kind of wiggle the screwdriver back and forth and it'll come out. What that does is that put the screw and put tension onto the axle, and it's pressing up against the flat of that axle. So now the collar won't slide back and forth anymore. The collar is stuck on the axle. It won't rotate. It won't slide back and forth. So that's great if you want to put a wheel on there, for instance. You want to put your wheel on there, and you want to make sure your wheel doesn't slide too far over. You can put that on there, and all of a sudden your wheel will stay right there on the axle. You can put another one on that side, and then the wheel will stay permanently on that axle until you loosen that screw and take it off. So you can take the wheel off and use your screwdriver here, and then loosen it a little bit, and it'll come right back off. And you always want to try to make sure that we keep that tiny little set screw inside of the collar. And then the final screws we have are these tiny little baby screws, okay? If you compare them to the standard 832 screws, you'll see that this is a standard screw, the 832. So remember, it's 8 wide. These guys are much smaller. These are 6. So these guys are 6 wide. Okay, so these used with cap nuts and collars, caps, nuts, and standoffs, etc., etc. And that's what those are used for. Those are your most common ones. But if you look inside of your motors have these little tiny thread inserts. So that's what these guys are for, is that these guys are smaller, so they can screw into here, and then they'll tie them down, and that's what holds the motor on. So these are commonly referred to as motor screws. And there's 2 different sizes. There's this tiny little baby size, and then this longer size, and that's all the sizes they have. But this is how you attach your motor to your piece of metal. Use these tiny little baby screws. And then, since they're smaller, you can't use your 3/32 Allen wrench. Instead, we use a 5/64. which is a little tiny bit smaller. So if you ever have your 832 and you're trying to use your Allen wrench and it's just kind of spinning, it may be stripped, but you may have the wrong Allen wrench. So make sure you get the right Allen wrench for the right screw. And then same thing, if you have too big of a Allen wrench, the Allen wrench won't fit inside the screw. Make sure you have your right Allen wrench and make sure that gets in there, and then you can screw it in. And then these are the same thing as the other screws, is these can easily be stripped. You can be very careful, make sure your wrench is good, make sure your head is good and everything. And then just like before, they have black ones, which are their older ones, which can strip faster. And they have these gold ones. And that's another way you can distinguish the different colors, is different motor screws, is that the standard screws, the new ones are silver. The motor screws, the new ones, are gold. And then also you can see this little red piece on here, the tiny little red piece on the threads. That's a lock. It's just like we talked about in the nylon nuts. It's a piece of fabric or nylon material, glue kind of thing. And what it does is that when that goes into your nut or your motor or whatever you're putting into, that provides tension on the screws. So as you can see, I can put this guy in here and I can spin him, and he's really easy to turn. Okay, that's because there's no material on threads. If I put this guy in and I try to turn him, he's really, really hard to turn. Like, I can't turn him very well. So I can then take my 5/64 Allen wrench, put it in there, and then use that to tighten it down. And then that will prevent the screw from coming out. Because one of the worst things you can have, other than stripped screws, is your motor screws coming loose, and then your motor just falls off of your robot, and all of a sudden you can't move anymore. So those are really nice, and you don't really need many of them because you only need 2 per motor. So in theory, you'd only need 20 at the most. And then those are your different screws. And then just like before, for the 5/64, you have your 5/64 T-wrench, T-shaped, and your standard kind here. But they don't have a ball head on them because the Allen wrench is just too small for a ball. So this is just another style we have as well. And of course you can get your little L ones as well. And those are the screws and hardware. Sorry for the long video. We'll go more depth in a little bit. Thank you.